Well, hello there, what's up? We're here for section 11.2, and this section's all about surface area of prisms and cylinders. Hopefully a review for you since we're already in geometry and you have done this before, but it's a good review nonetheless. We're going to focus in on the goal of finding the surface area of a prism and of a cylinder. Alright, so surface area. We've done for sure volume. We'll see if we remember how to find surface area of these three-dimensional figures. So, to start off, something essential to understand is to find the surface area of a three-dimensional figure, find the sum of the areas of all the surfaces of the figure. So, you're finding the area of all the surfaces, all the parts that would be on the outside of the figure. So, couple terms here. A prism. I kind of use the word prism and polyhedron interchangeable, but a prism is a polyhedron with two congruent parallel faces. So really, a prism has to have two parallel faces that are congruent. And those faces are called the bases. All right? And it totally depends on how the face or how the shape is sitting. For this one right here, it's the two bases are here and then down here. This one would be the triangles down here and up there. So you're not looking for, well, the other faces, the ones that are not parallel, not congruent, necessarily congruent, sometimes they are the lateral faces. And sometimes you just want to find the lateral surface area. You just want to find that part around it. So that would be part of finding the area, or the lateral surface area. You can name a prism by using the shape of its bases. So if you look at the first one, that has 1, 2, 3, 1, 2, 3, 4, 5. So it is a pentagonal prism because it forms a pentagon. So it's pentagonal prism. And then this one has triangle as your basis, so it's a triangular prism. A common one is a rectangular prism. A cube is another common one that you've worked with. So, a couple more things to add to our list of vocabulary for this section. An altitude of a prism. An altitude, because these are all things we're going to use in finding surface area, but an altitude of a prism is a perpendicular segment that joins the planes of the bases. So in this case, it's just a side for this far left one. The one next to it would be, this is the one. So the bases, again, it has to join the bases. So the bases are the parallel ones right here. So it would be this side with one of these sides. There. If it's, these are called oblique prisms. Oh, so by the way, a little bubble here. The lateral faces are rectangles on these. A lateral edge is an altitude. So if we look at these oblique ones, either some or all of the faces are non-rectangular. So if that is the case, when we're talking about the lateral faces, this is a parallelogram, this lateral face. So you might have to have an altitude that is outside of it. As long as it forms the extended planes, a perpendicular line between the extended planes. All right? All right. So as we're going through, it does say, especially in our book, you can assume a prism is a right prism unless it's stated otherwise. Typically, that'll be how it'll be, unless it's very obvious that it's not a right prism. But either way, we can find the lateral area and the regular surface area. Those are two different things. So the lateral area is the sum of all the areas of the lateral faces. Whereas the regular surface area is the sum of the lateral area and the two bases. Or in other words, the sum of all um, areas of faces. So all the faces, so the faces and the bases. So that includes the lateral faces as well as the bases. So for finding surface area, we're finding the area of all the surfaces. So let's actually find surface area. Example 1 says, what is the surface area of the triangular prism to the right? Use a net. So a net is very helpful because it's a two-dimensional drawing, as you may recall, of a three-dimensional figure. So if I draw this, I'm going to draw that one lateral face. I'm going to do my bases like this. So those are the two triangles are the bases. So we have this is 6, and these are both 5. This is 12, 12, and 6, 5, 5. And these are also the length of 12, but these are 5 here. Because if you look at them joined, they would be 5. Alright, so there's our labeled net of that triangular prism. Now you got to find the area of all the parts. So in the inside, 6 times 12, that's 72. In here, 5 times 12 would be 60. So it's also 60. Now you just have to find the area of this one. So if I look at that triangle, um, we got to either use the area of the base, sorry, the base times the height divided by 2, 1/2 base times height, or the other theorem that has included an included angle on two sides, but we don't have any angle measures. So we're going to try and find the height. So let's take one of these out here. I'll put the 6 on the bottom and the two 5s like this. And I'm going to try to find this height. So if I know this is 3, then this is 5. I can do the Pythagorean theorem, 3 squared plus x squared, what we're trying to find, would be equal to 5 squared. And if you do figure that out, x is going to be equal to 4. That's a Pythagorean triple, 3, 4, 5, so that's how I knew that one. So that means that this height is 4. So to find the area of each of those, you do base times height divided by 2. So 6, or 1/2 base times height. So we're going to have a 12 will be our area in there. Add them all up to find the regular surface area. 72, that is a 7, not a 2. 72, 60, 60, 12, and 12. I'm going to add them up here. Traditional way here. Carry the, oh, we don't have to carry anything there. So 7 plus 6 plus 6 plus 1 plus 1. 12, 14, 21 it looks like. So 216, I hope I did that right, centimeters squared. This area is squared. Alright? You can find formulas for lateral and surface area of a prism by using a net, and that's kind of what we just tried to do. The perimeter of the base is A plus B plus C plus D. That's the perimeter. So lateral surface area, or sorry, lateral area of a rectangular prism like this would simply be whatever the perimeter of the base is, so whatever this is, times the height. That would get you the lateral area. That's actually really nice. Um, and if you take the surface area, again, what I did with this one up here, and you probably did the same thing, was find the area of each one. That's a way to do it. So it may be a little bit longer, though. So a shorter way would just be simply this right here. So if we found the area of that, all right, but the surface area, regular surface area, would be the lateral area plus 2 of the bases, so the area of the bases. All right, so let's try to use that a little bit here. And that's what theorem 11.1 is. So lateral area of a prism, lateral and surface areas of a prism. So P is the perimeter of the base. Capital B is the area of the base. So example 2, find the lateral area and the surface area. Lateral area and the surface area of the rectangular prism. So lateral area, we're going to just simply use the area of the base, which we'll say is 8 times 3. Sorry, the perimeter of the base. So 8 plus 8 is 16, plus 3 is 19, plus 3 is 22. So it's going to be P times the height, which is equal to 22 times 5, which would be 110 centimeters squared. Now, the surface area would be that, 110, plus the area of the base twice. So 8 times 3 would be 24. I'll divide that by 2 because there's 2 areas of the base. 110 plus 48 would be 158 centimeters squared. Why don't you try that in example 3 here. Find the lateral area and the surface area of the triangle prism. And note, the bases. The bases are the ones that are parallel and congruent. So this is one base, and this is another base. So go ahead. So finding those two things, I first had to figure out that the bases, I found the area of the base and the perimeter of the base, because those two things help. They both happen to be 30, so that was interesting. The height of this whole prism, if you put it so that it's from base to base, would be, or the altitude would be this 6. Okay? And I found this third side of the triangle, the bases, by using the Pythagorean theorem. That would be 13. Used the formulas and found the lateral area to be 180 and the surface area to be 240 feet squared. Alright, here's one more example we're not going to get to right now. We're going to go on to this other part. So, cylinders. When we're looking at cylinders, a cylinder is a solid with two congruent parallel bases that are circles. An altitude of a cylinder is a perpendicular line that joins the bases. So an altitude or the same thing as the height. The height is the length of that altitude. So the height is right here. It's the height of that base. If it's an oblique one, it would be this perpendicular line to that. All right? And the bases are the circles. So those are the parallel ones. Most bases are right cylinders. However, they'll let you know if they're not. To find the area of a curved cylinder of the curved surface of a cylinder, visualize unrolling it. So think of a scroll or the wrapper around a camel suit. If you take that off, it actually would make a rectangle. So the area would be a rectangle of this whole outside the surface area that would not be the bases, and that would be the lateral area. The surface area would be that combined with the area of the two bases. So we're going to have to remember that the area of a base, well, I guess the area of the base of a circle, which would be the circles, the area of the circle would be pi r squared. And to find the two sides of that rectangle, that would be the lateral area, you need to find the circumference of the circle, because that would be the one side, and then the height, obviously. So it would be 2 pi r would be the circumference of that one side, times multiply that by the height, and you get that lateral area. And that's what we have right here. The lateral area of a cylinder would be 2 pi r times the height. So it's the area of the circle, or perimeter of the circle, times height. Surface area would be the lateral area plus 2 times pi r squared, because it's going to be the circle there. So the area of the base. Okay? So find the lateral area and surface area of this cylinder. So lateral area. Picture this unrolled. We have the height is 11. And we have that the diameter is 8. So to find the circumference of the circle would be pi times diameter, which would be 8 pi. So multiply those together to get the, if you unravel it again, it'd be 8 pi, and the height would be 11. So whatever that is equal to 8 pi times 11, which would be 88 pi. We're going to leave it as right now, feet squared. The surface area then would be that lateral area, so the 88 pi plus 2 times whatever the area of the base is. And the base we find by pi r squared, so it would be pi times 4 squared, which is 16. So we do that, we have 88 pi plus, that'd be 32 pi, which would equal a total of 120 pi. And I'm getting hungry for pi. I'll leave it as feet squared. Okay? That's how you find the lateral and surface area of a cylinder. That's the last one we're going to do actually right now. We have a couple different examples here that we can get to in class. You can try them on your own, which I would encourage you to do so that you're prepared for in class when we actually go through them, and you can ask questions if you need to, or just go on by yourself. All right? You please answer the two closing questions. What is the lateral area of a prism, and what is the surface area of a prism? Think about what the difference between those two things are. And that's the main ideas of section 2 in this chapter on volume and surface area. So we'll go back and look at your goal and see how you did. And we'll see you next time. Have a good one.